After a long interval of time, we are again meeting together. You have just finished your periodic test 1. I hope you all have done very well. Okay? And now it is a time to focus towards half-yearly. So, one exam just after another exam. Chhatranang adhyan tapo. Your duty is to study only. Okay? So, whatever the chapters coming in different phase, already we have given you the split of syllabus, you follow it. Okay, little amendment has been done and it will be given to you very soon. Okay. Now, today I am going to start a new chapter, that is powers, exponents and powers. This chapter is not new to you. You have already come to know about this chapter in class 7. We have some knowledge also. So, before starting the chapter, whatever it is given in class 8, I like to recapitulate whatever you learned in class 7, number 1, and side by side, whatever the content given in this book, in this chapter, I am just giving you summary. So, just see the video.
Hi, this is Rob. Welcome to Math Antics. In this video, we're going to learn about the laws of exponents. If you look up the laws of exponents online or in a math book, you'll probably see a long list of equations that looks something like this. Wow, that's kind of overwhelming when you see them all at once. But don't worry, we'll take them one step at a time, and you'll see that they're not that complicated after all. But before we get going, if you're not confident with the basics of exponents, I highly recommend watching our previous videos about them before moving on in this video. Okay, let's start with just the first 2 laws on our list, which should look familiar if you watched our video called Exponents in Algebra. They're just the 2 rules we learned in that video. You know, rules, laws, same difference. So you probably already know them. They simply tell us that anything raised to the first power is itself, and anything raised to the 0th power is just 1. And because we already know about exponents that are higher integer values, like x to the 2nd and x to the 3rd, that means we've pretty much got things covered, right? Ah, not so fast. Don't forget that integers can have negative values too. For example, what if we had the expression x to the power of -1, or -2, or -3? We know that exponents are a way of doing repeated multiplication. But how in the world could you multiply something together a negative number of times? Well, you can't. Fortunately, the next law on our list tells us how to interpret a negative exponent. That law says x to the -nth power equals 1 divided by x to the nth power. And if you think about it, that kind of makes sense. A negative number is the inverse of its positive counterpart. And division is the inverse operation of multiplication, right? So a negative exponent is basically repeated division. X to the -1 would be 1 divided by x. X to the -2 would be 1 divided by x divided by x. X to the -3 would be 1 divided by x divided by x divided by x, and so on. Seeing it like this makes the pattern clear, but mathematicians prefer to express negative exponents in fraction form, where 1 is divided by the same number of x's multiplied together. But since those multiplied x's are all on the bottom of the fraction, you're actually dividing by all of them. Here's an example that will help you see that that's true. 2 to the -3rd power. Let's first try that as a repeated division problem like our pattern shows us. We always start with a 1, so we would have 1 divided by 2 divided by 2 divided by 2. If we do those operations from left to right using a calculator, we get 0.125 as the answer. Now let's write it in fraction form like our law of exponents tells us we can. 2 to the -3rd power would be the same as 1 divided by 2 to the 3rd power. And that's the same as 1 over 2 times 2 times 2. Which simplifies to 1 over 8, and 1 over 8 simplifies to 0.125. See, whether you write it as a pattern of repeated division, or in fraction form, like our inverse law shows, you get the same answer. And now you know how to handle any expression with a negative exponent. It's just 1 over the same expression with a positive exponent. X to the -1 is 1 over x to the +1, or just 1 over x. X to the -2 is 1 over x to the +2. X to the -3 is 1 over x to the +3, and so on. All right, 3 laws down, 5 more to go. And these next 5 show us how we can do various math operations involving exponents. In fact, the next law tells us how we can take a number raised to a power and then raise that to a power. As you can see, it shows an expression, x to the power of m, grouped inside parentheses, and then that whole group is being raised to the nth power. It's a nesting situation, kind of like those Russian nesting dolls. So what if someone asks you to simplify the expression x squared cubed, which means the entire x squared term is raised to the third power? Well, our law tells us that we can simplify that by multiplying the exponents together. See how it equals x to the power of mn, which means m times n? That means x squared raised to the third power would be the same as x to the power of 2 times 3, which is 6. Want to see why that's true? Well, think about what it would mean to raise x squared to the third power. It would mean multiplying 3 x squared terms together, like this. And each one of those x squared terms simplifies to x times x, right? So we end up with 6 x's being multiplied together, which is just x to the 6th power. See, our law works great. If you have a number raised to a power, and that's all raised to another power, you can just multiply the 2 exponents together to simplify it. And it works for negative exponents too. Like what if we had x squared raised to the negative third power? Well, our law tells us that that's the same as x to the power of 2 times negative 3, which is x to the negative 6th. To see if that's true, we'll need to use the law we just learned about negative exponents and rewrite this as 1 over x squared to the positive third power. That simplifies to 1 over x squared times x squared times x squared, which in turn simplifies to 1 over 6 x's being multiplied together. And that all checks out, because 1 over x to the 6th would be the same as x to the negative 6th power. Pretty cool, huh? Okay, we're halfway through our list of laws, and we're going to look at the next 2 as a set, because they tell us how we can multiply and divide expressions that have the same base. And that's important because we couldn't simplify them to have a single exponent if the bases were different. The first law says that if we have the base x with exponent m being multiplied by the same base x with exponent n, we can combine them simply by adding the exponents together. And the second law says if we have the base x with exponent m being divided by the same base x with exponent n, we can combine them simply by subtracting the exponents. Let's see some examples of each, like this one, 2 to the third times 2 to the fourth. Does that fit the pattern of our first law? Yep, the base of both expressions is the same, but they happen to have different exponents. The law would still work if the exponents were the same, but they don't have to be. Just the bases have to be the same. Our law tells us that this would equal 2 to the power of 3 plus 4, or 2 to the 7th power. But does it? Well, let's break it down and see. 2 to the third is 2 times 2 times 2, and that's being multiplied by 2 to the fourth, which is 2 times 2 times 2 times 2. That's a lot of 2's being multiplied together, 7 2's to be exact. Aha! So that is what you'd get by just adding the exponents together, since 3 plus 4 equals 7. And this law makes total sense if you think about what an exponent really means. The exponent is telling you to do repeated multiplication of the base, right? So this first part is telling you to multiply 3 2's together, and the second part is telling you to multiply 4 2's together. So that's why you can add the exponents together if the base is the same. Or think about it like this. If we had 10 x's all being multiplied together, we could form different groups of them and combine them using exponents. Like we could combine the first 4 x's into x to the fourth, and combine the remaining 6 x's into x to the 6th. And of course those expressions would be multiplied together since all of the x's were being multiplied. But you'd probably never want to do that, would you? I mean, why not just combine all 10 x's into the expression x to the 10th? Ah, but there you see that our law holds true. X to the fourth times x to the 6th would equal x to the power of 4 plus 6, or x to the 10th. Okay, now let's move on and see some examples of the second law in this set, which tells us how to divide expressions with the same base. Suppose we have the expression 5 to the third power divided by 5 to the second power. Our law says that we can simplify this by subtracting the exponents. Specifically, we take the exponent on the top and subtract the exponent on the bottom from it. If we do that, the simplified version would be 5 to the power of 3 minus 2, or 5 to the first power. But is that right? To see, let's write the expression out in expanded form. On the top of our division problem, we have 5 to the third, which is 5 times 5 times 5. And on the bottom, we have 5 to the second, which is 5 times 5. Does this look like something you've seen while simplifying fractions? Yep, since all the bases are the same, they form pairs of common factors on the top and bottom that can be canceled out. This 5 over 5 cancels, and this 5 over 5 cancels. If you don't know why that works, be sure to watch our video about simplifying fractions. And what do we end up with? Well, all the factors on the bottom canceled out, which leaves 1 since there's always a factor of 1. And there's only one 5 left on the top. So our expression simplified to 5 over 1, or just 5. Following our law, we got a simplified version of 5 to the first power, which is also just 5. So it really did work. But to make sure you've really got it, let's try using this law again with the expression x to the fourth power over x to the sixth power. This one's interesting. Our law says that we can simplify it by subtracting the bottom exponent from the top, right? But in this case, that will give us a negative exponent because the bottom exponent is bigger than the top. 4 minus 6 would be negative 2. So according to our law, this expression should be equal to x to the negative 2. Let's try writing it out in expanded form to see if that's true. On the top, x to the fourth would be the same as 4 x's multiplied together. And on the bottom, x to the sixth would be the same as 6 x's multiplied together. Once again, we see that there are pairs of common factors that we can cancel. 4 pairs to be precise. And when we cancel them all, we're left with a 1 on the top, because there's always a factor of 1, and only 2 x's multiplied together on the bottom. If we recombine these 2 x's, we get 1 over x squared. And if you remember the law we learned earlier about negative exponents, you'll see that 1 over x squared is exactly the same as x to the power of negative 2. So these laws really do work. Okay, it's finally time to look at the last 2 laws on our list. And fortunately, they're pretty easy ones, so we're not going to spend too much time on them. These laws look kind of similar to the last pair. Just like before, the first one involves multiplication and the second one involves division. But notice that in these laws, the bases are different, but the exponents are the same. That's the exact opposite of the situation with the last pair of laws. It turns out that these laws aren't about simplifying exponents, they're about how you can distribute or undistribute a common exponent to different bases. The first law shows this group, x times y, that's being raised to the power of m, and it says that you can rewrite it as x to the m times y to the m. In other words, you can distribute the exponent to each factor in the group. And the second law shows the group, x divided by y, that's being raised to the power of n. And it says that you can rewrite it as x to the n divided by y to the n. In other words, you can distribute the exponent to each part of the fraction. Of course, these laws would work in reverse too, and you could undistribute the exponents if they're the same. For example, if you're given the expression x squared times y squared, you could rewrite that as the quantity x times y squared. And if you have the expression x squared divided by y squared, you could rewrite that as the quantity x over y squared. Here are 2 expressions that will help you see why you can distribute or undistribute exponents like our laws show. In the first expression, we have the quantity x times y squared, and that's the same as x times y times x times y. And the commutative property says that we can rearrange those factors like this, x times y times y. But look, we can simplify that into x squared times y squared, so that checks out. In the second expression, we have the quantity x over y squared. That's the same as x over y times x over y. To multiply these fractions, we just multiply the tops and multiply the bottoms, which gives us x times x over y times y. And that simplifies to x squared over y squared, so that one checks out too. Alright, so now you know about the so-called laws of exponents. And there's a good chance that you'll see them explained in slightly different forms or different orders, or even using different terminology in other math videos or books. But the basic ideas will be the same. Some people like to try to memorize this list of laws, and you can do that if you want to, but it's an even better idea to focus on knowing how exponents really work, because if you truly understand that, you can actually figure out a lot of these laws for yourself. And what's the best way to understand how exponents really work? Yep, you gotta practice. So be sure to do some problems with exponents on your own. As always, thanks for watching Math Antics, and I'll see you next time.
I hope you have understood very well what is exponential power, what are the uses of exponential power. You have already come to know. So already the laws are given here. I don't know how many you are able to write. So I am giving you the laws of exponents on the basis what calculation you have to do. So you have to write down here what are the laws of exponent. Mind it, exponential powers. These are basically used to represent when a number is very big or when a number is very small. Say size of a bacteria, size of microbes. I have to express it in terms of measurement of unit, centimeter, millimeter, meter, whatever it is. Distance from the sun to earth. Okay, I have to represent it with the help of number. So how do we represent that big number in a short form? That is the use of exponential power. Okay, so first I am giving the law. First, laws of exponent. You write down laws of exponent. Laws of exponent. Okay, first laws. Number 1, say a raised to n multiplied by a raised to m, where a is any rational number and n is the what do you say, whole number. In this case, you will take whole number only. When you will come to class 9, we have to take a rational number. What do we say? Fractional rational number form. Or here only you have to take whole number, either positive, negative, or 0. Understood? So when two rational number having the same base, two rational numbers same, powers are different. These two are called powers. Powers are different. Then what to do? Okay. So we have to add the power. In case of multiplication, we have to add the power under 1 this. So here instead of a, you can take m, x, any alphabet, and also this one you can take any alphabet to represent the power. Okay. Number 2, in case of multiplications, the main concept is what? We are adding the power when the base is same. So now a raised to n divided by a raised to m. So same thing, instead of multiplications we have divisions. What to do? Then we have to subtract the power. Okay? A raised to n minus m. You have to remember the n is greater than the m or whatever it is. After subtractions, whole number subtractions, you can get the result. Now number 3, when two numbers, number 3, this is very very important and its use is maximum in class 9th only. Say write down a raised to n multiplied by b raised to n. Okay, this is in the form of distributive form. We have to what? We have to write down non-distributive form. As you seen in this video also, this using maximum in class 9. So we can write down, in case of multiplication, we have to multiply the base under 1 power n. So that means when two rational number having different base, the two different rational number having the same power, so we can group or non-distribute, or when this form is given, a into b raised to n, and your requirement we have to split the number, so we can write down this. So this is the distributive form, this is the non-distributive form, and this question on the basis of these laws, maximum number of questions you will be getting in class 9. Okay, it's used. Now same way, number 4, a raised to n raised to m. Okay, when two rational number, one irrational number having double power, inside, outside. So I can, or we can write down, we can see this for our requirements. I can write down here a raised to m raised to n, or we can write down here a raised to mn, m into n. When the situation arises, whatever the situation arises, we have to write down the right form of these laws. So this is the fourth law. First one is in case of multiplication, we have to add the power when the base is same. When the base is same, division case, we have to subtract the power. When two different rational numbers having the same power, we have to non-distribute. It is the distribute form, it is a non-distribute form under one power. Okay. When a rational number having double power, so inner power we can write down outside, outside power we can now inside. No problem. Or two powers we have to multiply together. Okay. Now next one is fifth. Any rational number raised to 0. You have already come to do in class 7. Directly you can write down 1. Why? Because that proof also have to given in class 7. Any rational number raised to the power 0 equals to 1. Okay. If requires, I can prove it. Sixth, any rational number, say a raised to n, that can be written 1 by a raised to minus n. Okay, inverse. Okay, when instruction is that show the result in negative. So negative of any power is just reciprocal. Okay, we have to reciprocal the base. A 1 by a raised to or you can say minus 1. Okay, 1 by this, or 7, just opposite one is given, 1 by a raised to n. This formation is given. Okay, so then what we can write down? Reciprocal of this is equal to minus n. Okay, that means when positive powers, we have to write down in negative form, we have to reciprocate the base. That means inverse of the base. A means a by 1, when reciprocate will be 1 by a raised to minus power. Okay, when this power is given already, clear? A raised to n. Positive power is seen in the denominator, I have to show in negative. So just reciprocate the base, it will be negative. Okay. Now, one more loss will be there. When it will come to our calculations, we definitely will give you negative base. A raised to n, a raised to n. Already this distributive and non-distributive form maximum use is given. Clear? Whenever any situation is coming, I will be giving you some other laws also. Clear? So for time being, I am just starting your exercise on the basis of these 5 laws. In case of class 8, so maximum use will be the negative exponent. Okay. Already you have come to know about the calculation how we do in case of positive exponent. So in class 7. So here the maximum use will be negative exponent and some x value. So after finishing this exercise, I will be giving you so many questions, nice questions. So if you are able to do it, you will never face any problem in class 9. Okay. I think you all have written it. If you have not written, pause the video, replay it again and again. And it's same. Whatever the video clip I have shown you, if you go through once, you will never understand. You have to replay it again and again. Okay, then only make out what actually the concept likes to follow. Okay. Now I am solving some textbook question. Whenever you face any problem, I just know that your problem area. Exercise 12.1. Clear? Exercise 12.1. Evaluate. Question number 1. Evaluate 3 raised to minus 1. When evaluate minus 2. When evaluate, find the value, simplify. Meaning is same. We have to get the result in number form. Okay. And sometimes already instruction is given, show the answer in exponential form. Okay. So you have to result show in exponential form. Two forms are there. One is called exponential form. I am showing you what is this called? This is called radical sign. Say this is a. Okay, root over a. It is a root sign. This formation is called radical sign. Same way I can represent it 1 by this exponent. Okay, now it is in the form of rational number. So whatever I have shown in radical form, this is called exponential form. Also meaning is same value. Okay, or if you have this way 4 root this is the power, and this is a radical form. When you write down in exponential form, first you have to a raised to 2 power and multiplied by the order. This is the order. This form is order radical form. What is the form? 4th root. This defines 4th root. This is square root. If I write down 3, it will be 3rd root. If I write down 5, 5th root. If I write down 6, 6th root, and so on. Okay, and that you have to write down 1 by 4. Cut it 2. That equals to a raised to 1 by 2. Understood? This expression is very, very important for class 9. This is radical form and same value exponential form. Sometimes we have to represent the radical form to exponential form and exponential form to radical form for our calculation. We have to remember both having the same value. Only thing is that maximum cases when the number is given radical form, we have to write down in exponential form. After that, cancelling is possible. Cancel, then we get the result. Understood? Two forms: radical form, exponential form. Now here find the value. What is the power? -2. So I told you when the power is negative, I cannot find the value. We have to make it positive. How? Negative. Just to have shown the laws. Negative power we convert into positive. Then we have to reciprocate the base. 3 can be written 1 by 3. 1 by 3 raised to positive 2. Or you can write down 2 here also, no problem. Actually it was there only, that's only. So 1 square is 1, 3 square is 9. Answer. Got it? So negative exponent first convert into positive by reciprocating the base, and after that get the value. Now next number 2, -4 raised to -2. So write down. When you write down in a reciprocate form, I told you in the rational number, denominator should not be negative. So this minus sign will be here only. Only the number 4, 1 by 4 raised to 2. Now, interesting fact, 1 square is 1, but when negative number is there, so square of negative number is positive. Okay, so then it will be -1 equals to 1. And this one is the 4 square is the 16. Answer. Any problem? I think you should not have any problem. If you are following my instruction properly, so you will not face any problem. I will take 3 classes on laws of exponential and powers. Okay, and I will give a lot of questions also. Then I will come to your chapter cube and cube root, and lastly playing with number, interesting part. Okay, then I will be able to cover your syllabus for half-yearly exam. Then I will start revision again. So before half-yearly, we have to complete 10 chapters, and out of 10 chapters, how many chapters will be coming, we will decide later on. Okay, I will not give you any burden. Okay, I will reduce the syllabus, but we have to cover whatever the chapters given before half-yearly exam. Understood? Don't worry. I will reduce. This time we have given only 3 chapters. Similarly, we can give little more, but not the 10 chapters at least. But we have to complete 10 chapters before half-yearly. And half-yearly, your calendar, we have sent to calendar PDF file. It is mentioned in September, but we are not going to conduct in the month of September. Okay, we will conduct it in the month of October, and after half yearly we will have autumn break. Okay, nice schedule. And now third one is what? Third one, 1 by 2 raised to minus 5. So negative number, when you make 2 positive, it will be 2 by 1. We don't write 1. This now maximum students are doing mistake when they get the final. What is the result? 5 to the 10. No, it is not like that. I have to write down 2 5 times and then multiply, not 5 to the 5 times 2 itself multiplied. Okay, so that means you have to split the number 2 into 2 into 2 into 2 into 2, not 5 to the. Maximum number of students doing mistake here only. You should not mistake like this way. What is the meaning of power? You have to write down the base that many times. After that you multiply. 2 to the 4, 4 to the 8, 8 to the 16, 16 to the 32. This is the answer. Got it? Any problem? No problem. Okay. Now, next one, question number 2. Instruction. Simplify and express the result in power notation with positive exponent. No need to find the result in number. You have to show the result in exponential form, and that exponent should be positive one. If it is coming negative, then you have to show in positive form, and if it is already positive, no need to express in other form. Okay. And what is the rule? When negative, we have to convert into positive form, reciprocate the base. We have to calculate each and every part, and at the final stage, we have to just reciprocate the base. Understood? Okay. Now question number 2, 1. So minus 4 raised to 5 divided by minus 4 raised to 8. What is the similarity you are getting? Tell me. Base is same. What is the second law? When two rational numbers having the same base and different power, in case of division, we have to subtract the power. So what we do? So we have to write down minus 4 raised to 5 minus 8. So that will be equals to minus 4 raised to minus 3. So finally the result is coming what? Result is coming in negative exponent. But instruction is you show it positive. How will you do? When negative exponent convert into positive, what to do? We have to write down in a reciprocal form. But minus sign, where it will be? 1 or 4? It will be 1 only. Understood my point? Have understood? Now next number. So your question is this. Final calculation up to this. But instruction is positive exponent. How will you do it? You have to reciprocate the base. And if the number is negative, so negative sign will be with numerator only, not with denominator. Now next number, 1 by 1 by 2 raised to 3 raised to square. So what will be the result? You see, 1 square is 1. You can apply that from when this law, a raised to n raised to 3. That will be what? A raised to 2 3 is 6. Inner power, outer power, you have to multiply. That rule you have to apply. But it is with the 2 only, not with 1. If I write down 1, no problem, because 1 multiplied by several times, result is 1 only, no problem. So what will be the result here? 1 by 2 raised to 3 to the 6. Where any number having double power inside and outside, we can do one more thing also. 2 we can write down outside, 3 we can write down inside. This distributive form and non-distributive form and splitting the number, I am telling you, you have to be very serious, because maximum questions you will get in class 9 on the basis of these two laws. Okay, whenever you require that 3 should come inside and 2 should go outside, you do it. Okay, you can convert the position, you can replace the position of these 2 power whenever it requires. But this application is not in class 8, but you remember this type of calculation may come. Now next, 3 minus 3 raised to 4 multiplied by 5 by 3 raised to 4. What similarity you are getting? Which law you can apply? Each and every question you have to try to apply law. Okay. What similarity you are getting? 2 rational numbers having the same power. This, it is in a distributive form, we can combine non-distributive form. Okay, 2 powers. So we have to write down both the rational number under 1 power, minus 3 into 5 by 3.